By end of this video, you will know how I created this beautiful application with end-to-end machine learning project. From zero to creating this application, to just predict the lead scoring. Lead scoring means how is the chance for this specific customer to come back to our company and purchase this product. We are going to build this application step by step to find out what is the possibility for a customer to use our product. This application is built for a SaaS product. All right, first let's talk about the project structure. Project structure is just the fundamental of every single project that we want to do. It might be different project to project because every single project has its own requirement. And based on the requirement, we just created the specific structure. I'm going to explain the structure for my project. And after that, we can go one by one to understand what I did. Definitely during this video, I'm not gonna do live coding because this project is a comprehensive project and I'm not gonna waste the recording of this video for live coding. But it is important for you to understand the logic that I did and all the steps that I walked through during this project. As you can see here, we have some folders and I'm going to explain one by one. I used this folder for which purpose, and after that we can go step by step. And I'm not going to explain from top to bottom. I'm going to explain from the step that I did in a project. The first folder that we are going to talk about is the data. In this folder, we understand what is the data that we have and which kind of problem that we are going to solve. After that, we should talk about the utils. The utils is also very important because it stores all the utilities, all the function that I use during the project, and I use the utils file because utils can help me to save the time instead of writing one same functions too many times. I just read from the utils. I write once in a util, and wherever during the project I need it, I just call that function. The next folder is just notebook. Notebook is also very important. It is the initial step for every single project because in the notebook, we understand what we are going to do. We understand everything about the data. Definitely in this step, we don't do any fancy things. It is just the wrangling data to understand data much better. And surely we will do the same steps later on during the project, like what we did in experiment. But that time we use the script and not the notebook. We just run the notebook to trial and error the process that we want to do. After the notebook, now it's time to go for experiments. Experiment means, okay, now we are familiar with the notebook, so we need to find the model. And we run different experiments based on the steps that we did in a notebook. And I use MLflow to track the experiment because MLflow, I guess this is one of the best tools for tracking the experiment. And you know that in an ML project, we will have many metrics, many runs. If I want to just track them manually, it's so difficult. So I use the one tracking experiment tools, which is called MLflow. After we are okay with experimentation, so it's time to do all this process as the script. And this time we go for training pipeline. In training pipeline, we do all the steps from the raw data, pre-process, train the model, and evaluate the model in the one script. Not one script, I mean during the pipeline. Different components in one single pipeline. but it goes back all the way from what we did from the initial step of the project till now. And it helps us to have producibility and reusability in our project. And you might ask question, why, when we did it in Notebook, why we are going to again use training pipeline? Because all those experimentations, all those notebooks, they were only for understanding what we are going to do. When we are sure about the process, about the codes, about, for example, this pre-process technique is important. This column should be dropped, or we are going to use this model with these specific parameters because, for example, it's not overfit or underfit, and we are happy with all the metrics. Now everything is okay. We go all the way back and do all the steps, but this time we know which step we are going to go. Now training of the pipeline is okay. We should say, okay, now we have the model and it trained so well. We tested in that test data, but I like to see how does it work in unseen data, totally unseen data. So this time we go for inference. In inference section, we say, okay, I'm going to use my model or all the way that I did in a pipeline. And this time I'm going to use the model on unseen data to see how does it predict. Now this time we can go for very interesting sections of the project. This time we go for deployment package. Deployment package, it means we are encapsulate. We are packaging everything that I did, which model we definitely know after experimentation. We package that model, we package the pre-process, we package all the artifacts, and we just encapsulate everything as an API. And the last step of the project definitely is the step that we are going to see the results and just present for stakeholder. And this time we go for frontend and just shows the final result for our stakeholder. Definitely, all these steps is even beyond for a data scientist skills. In some steps, even we are going one step further as an ML engineer, but as a data scientist, we should know what is the step. And that's why I prefer to even create one simple application to show the model works. The model is not only working as a code, it works as an application. But definitely, if this application is going to deploy on a server, on a cloud, or on-premises system on a company, this time the software engineer, the ML engineer should come and play a role. Also, we have some folders. For example, we have my env. This is just the basic environment, because for working on a project, I prefer to have the environment isolated from other projects. Because you know that I'm using my project as the separate folder. And all these things are happening inside this folder. So just because I'm going to isolate my project or this project from other projects, I should create a different environment for this project. We have one file as a requirement.txt, and this file is also very important because I install whatever I needed, which packages, which libraries, everything that I needed, I install for my project inside my environment. And just because I'm installing my requirement for this specific environment and for this specific project, the other projects, they are using their own environment and there is no any intervention between them. And everything is working on different projects. Okay, now we can start from the data folder to get familiar with the data. All right, let's start with the data. If I open the data, you see we have two folders. One for pre-processed, and the other one is for raw data. This time, these folders are very important because they are the initial step for the project. I'm going to first show the raw data that I used for this project and explain the data and get more familiar with the data. This data is just the SaaS data or software as application data. As you can see, we have several columns at the first row, and this is just a CSV file. For example, we have customer ID, we have age of the customer, we have gender, we have country, from which country our user are just purchase our product. We have size of the company, because definitely that customer is working in a company and they are going to purchase our product for a company. What is the size of the company, in which industry that company is working, what is the job title of that person who is contacting with us, what is the annual company revenue, how big the company is, months as a customer, how long they are using our product. Or for the rest, if I go to the right, we can see more even. For example, how much they spend for this product as a total, how many times they purchase our product in a different platforms, what is the last purchase days ago. For example, for this specific user, 7 days ago they purchased our product. Previously they churned or not, this is very important. Whether they have ever used the discount in a system or not, how months they have been active in our system, average of session duration they are using our system. These are some kind of important metrics for marketing even. And also we have more columns. As you can see, I'm not going to explain one by one. You can open the file and see what they are. But we have a bunch of different columns here. And definitely this is our target column. Will purchase or not? And 1 means definitely they are going to purchase our product again. And 0 means these are going to not coming back to our product. And they are not going to repurchase our product anymore. So these are all the data in terms of the column. In terms of the number of the rows, you can see we have 10,000 records. This is not very big data, but in terms of the reality, it is super close to the real SaaS data. And this project is a SaaS lead prediction. And overall, we are trying to help our company, which products this SaaS platform, to understand the behavior of the customer much more. All right, I just explained this section, SaaS data CSV, inside the raw folder as a subfolder for data. Now we can go for the next step. All right, now I'm going to talk about all the requirements during the project that I use. Definitely I use this requirement in different sections of the project, and it doesn't mean I'm going to, at the initial of the project, I know whatever I want. No, during the project, sometimes, for example, I think at the beginning of the project, I think, okay, I'm going to use Pandas version 2. But during the project, I noticed, oh, maybe the Pandas version 3 is useful. So I work with this requirement over and over during the project. And this is the final requirement. Okay, first of all, let me explain the first section. These are all the libraries that I needed as a core for my project. It means if I didn't have any of these libraries and packages, I can't do anything. They are the basic, they are fundamental for my project. I use Pandas, I use NumPy, Stat Model, Scikit-learn, MLflow, LightGBoost, XGBoost, Matplotlib, and Seaboard. I use all these things for having the fundamental for my project. Also, in the next step, I use Optuna and DVC for my project. I used Optuna for hyperparameter tuning, when I wanted to find the best parameters for my model. And I use DVC or data version control for building the pipeline and encapsulate all the components that I used for my training pipeline. These are all the libraries and packages inside the requirement txt. Okay, the next file, I should go to the utils folder, and inside it there is a file which is called feature.py. What is this file? This file is all the features that I have in my project. If I take a look at the Excel file again, you see we have 29 features. So 29 features means if I go here, we should have 29 features here for numerical, for categorical, targets, and just remove the columns. Let me explain one by one. In the first step, I categorized some of my features as a numerical columns because I'm going to treat them as the numerical way during the scaling. During all the pre-process steps, these are my numerical column, and I would like to treat them separately. For example, age, annual company revenue, months as a customer, total spend, so on and so forth. Overall, we have 16 numerical columns. We have 16 numerical columns. Also, we have 11 categorical features. What they are? The categorical columns are in these sections. We have all these categorical here. We have gender, we have country, we have the company size, industry, job title, so on and so forth. Again, I should know what are my categorical columns, what are my categorical features, because I'm going to treat them separately for encoding. Some of them should go with label encoding. Some of them should go with one-hot encoding. It is different, and based on the context, based on the number of the values, the distinct values they have, we should treat separately and differently. These are my categorical. Also, for every single ML project, we should have a column for the target. What is the target? The target is will repurchase or not in our dataset. This is the target. And also it makes sense just because we are using the real world scenario. There are some columns that they don't want it definitely. They don't bring any impact, any good impact in our project. And having them just increase the complexity, and increasing the complexity leads to having the overfitting in our. So it is good to just remove those kind of columns. And I just mentioned here which kind of column that I would like to have the removed column. So overall, I have 4 lists: numerical column, categorical column, target column, and remove column. They are all features in my project, and I listed them here to later during the project I make the feature spec file for my project. Alright, the next file that I'm going to talk about it, which is super important file in my project, is Utils. If I open the Utils py, it is just a Python script. I use this utils file as my repository for all the functions, not all the functions, the most common functions that I use during my project in every single section. For example, if I want to pre-process data, if I have a function, I don't need to write this function over and over again. I just write that function once in one file, and later during the project, whenever I need, I just call this file and call that function. Let's go one by one to understand what this file has. The first step is just the libraries that I need for writing this script for every single function. I need pandas for just working with tabular format. I need OS for working with different folders and different paths and location in my project. I use a stat model for variance inflation factor VIF to see the correlation between the features together. We will see all of them during the notebooks. I import NumPy, definitely. I use scikit-learn model selection for train and test split. I also use a standard scalar label encoder and one-hot encoder for dealing with numerical and categorical columns. And I also need joblib to dump any process or any function that I need as a pickle file, that whenever I need it, I just call that pickle file instead of calling the function. In the next step, we can go one by one to understand which kind of function that I have. The first function is just loading the data. I created a function to load my data. So what does this function do? It is so simple. This function is going to go to raw data, in data, and raw data, you can see here, and it's gonna read the CSV file that we have it here. This file is just gonna be read. And after that, store that file as just the pandas data frame. That's it. It is just a function that I call this function as load data. Whenever I need to load my raw data, I use this function. During the notebook, we will see. I'm just explaining the function for this project. The next step, or the next function, which is a big function, it is for data checkup. Data eyeballing is very important. I mean, in a project, we can't jump to the modeling or jump to the exploratory data analysis without knowing the data. We should know the number of the null values, we should know number of the rows, we should know which kind of columns do we have, what is the minimum, the maximum, the median, the standard deviation only for numeric type. And if we have the categorical, which kind of options that we have. For example, the country for our data should have 10 or 9 based on the data documentations. But if we have 20 different unique values, for example, maybe we have a spelling error in name of some countries, we should handle these kind of things. So I just created one function as a data checkup. And I use this function to run for my whole data frame to understand what is going on for my data. This is the second function. The third function is just checking multicollinearity. This function is also important because if we are working as a machine learning engineer or data scientist, we should be aware about the relationship between the variables. In our data, there might be some variables or features that are super correlated to each other. If we keep both of them, we just increase the complexity of the model. And increasing the complexity, as I said, causes the model overfit. But it has some situations. I mean, we can have super correlated features together, but if we use tree-based model or ensemble model like XGBoost, LightGBoost, random forest, these kind of models can handle. But if you're going to use a linear model like support vector machine or support vector classifier, logistic regression, and all kind of linear models, we should handle this linearity and this multicollinearity between the features. I just created this function to understand what is the relationship between my features. The next function is just target balance. We are working on a classification model. And in classification model, it's very important to understand whether our labels are balanced or not. For example, if one label has more records compared to the other label, we should handle this situation. There are a bunch of ways. We can use a smooth for undersampling. We can use stomach link for oversampling, or we can't do anything. Just during the train and data splitting, we should explicitly say a stratified sampling method to model knows when it's gonna just split data. It should split data based on the just imbalancing, to not push all the imbalancing for training and leave the test with just less amount of the records. Scikit-learn can handle, unless we don't say go with stratified, but we say. And the next function is train and data splitting that I just explained. We used this function to split our data, to train, test, and we should go with a stratified. If I go a bit to the right, you can see here I explicitly mention a stratified targets. And it means after putting this argument, scikit-learn handle the imbalancing in our data. It's not gonna just make the percentage of the labels together. During the splitting, it's consider this imbalance for train and test at the same time, which is very good. So we can go for last function, which is, I can say, the most important function for this file. This is a class and it's not a function. This is a class having two functions inside it. Preprocessor manager class is just handling everything about preprocessing the data. And after running all the steps, it's gonna store a processor pickle file after running everything. And this file is gonna store here, preprocess pickle file. It means after running these functions, we will have this file. But what is this class? Let me explain this class step by step. First of all, it starts with fit and transform preprocessing on only training data. And as you know, based on a feature that I just explained, we have two kinds of data. We have numerical, we have categorical. For numerical, it's just gonna scale the data based on a scalar. And for categorical, the story is different. For categorical, we have some kind of techniques. For example, for some of them, they have only two labels. It's gonna do binary. And if it has the binary, only 0 or 1, it's gonna use this technique. But if it is the binary and only two values, like for example, male and female, it's gonna use labeling code. But what if we have more than one values? In that case, we should go with one-hot encoding. So it means this function is handling 3 or 4 kind of data, numerical and 3 kind of categorical. And after that, it's just dump the file that I just explained here. This file is gonna dump the preprocessed pickle file. And this file is just fit and transform on train. Later, when we need to apply preprocess on test, we just call this file and transform on test. We don't fit on test because in that case we will have data leakage. Here, this is another function for this class. And this time, we are going to only call or load this function, and this time we are just gonna transform. We are not gonna fit, only transform. For scalar, transform for encoder, and also if I scroll down, you can see here we have some other techniques for encoding for test data. So it means after running this class, if we give a raw data for this class, finally this class scale the numerical, encode the categorical column based on their values. If they have two values, 0 or 1, just label encoding. If it has more than two values, it goes with one-hot encoding. And finally, it stores the process pickle file. Whenever we need it, we can apply it for testing. This is everything about the utils file. This is very important file for the project. All right, let's go ahead and go for working with notebooks. If I go to the notebooks, you can see we have 3 different files. We have balancing, we have exploratory data analysis, and we have preprocessing. I'm gonna start with exploratory data analysis at the first step of working with notebook. I open exploratory data analysis and let's go one by one. First of all, we need to import the libraries that we need. I just import the sys because I'm going to work with the different folders and different paths. I also add pathlib, it's also useful for that one. I import pandas and numpy as usual. The first step here, I'm going to import some functions from my utils file. If you know, in utils folder, we had one file as a utils.py, and inside it we have some functions. In this specific notebook, I'm going to use some of those functions. For example, I'm going to use load data function. I'm going to use data checkup for check that do we have any null values, any duplicate, or these kind of things. I also need to know about the multicollinearity, the relationship between the variables to see which kind of variables are super intertwined together. So I import all those functions to use them. Then for importing the dataset, and as you know, just we imported the load data, I just use that data, and the argument I use the load.csv, which is coming from the data file. And after that, if I import all these load data, these are the data set that we are seeing. We have the customer ID, we have age, gender, all the raw data we saw in an Excel file. Also, this is our target value. We successfully imported the data, but what's the next? The next step, we need to do some data eyeballing. Again, here, just because I would like to see all kind of columns, I just put the option for display everything that I have, and I want to see 4 decimal. And here I'm going to use another function from utils file, which is data checkup. If you want to see the details of this data file, you can just backward this video, or you can just open that utils file to go ahead and check this function to see what did it work. But let's see what we can capture from this function. For numerical one, you see which kind of things that we have. For all the numerical columns that I have here, we have something to say. For example, what is the number of the rows? Definitely all of them should be the same. Do we have any null values? What's the minimum? What's the maximum? What's the mean, median, and standard deviation? These are very important because, for example, if we have the age, that maximum is 120, definitely this is an outlier and we should exclude it from our training session. All this information are very useful when we want to work with numerical columns. This is only for numerical, but what about the categorical? Categorical, the first one is customer ID. We can just skip it. Let's go for the other. For example, for gender or for country, company size, industry, everything. You see number of the rows and we don't have any null values. And for each, you can see distinct values. For example, for gender, we have female, male, and other. For countries, we have USA, Canada, France, Australia, Germany, UK, Brazil, and India. We should make sure based on the data documentation. For example, if in data documentation it says we don't have UK, It means this UK is wrong and we should replace it with something else so we can handle it. For company size, we have some categories here for industry, for job title, and we have some plan type based on the platform that we are selling to our customers. Another function that for exploratory data analysis we use is for check multicollinearity. As I said, multicollinearity is very important, and as you can see here in our data, 2 columns, age and satisfaction score. VIF score is more than 10, and it means we should go into detail for those columns, because the VIF score is so high, it means they are some kind of multicollinearity. We should go into detail for those ones to see. So after running this, the first section, I would like to see what is the correlation between these two. These two, the VIF score is high, maybe just because they are super correlated with each other, but I see they are not even related to each other. Age has nothing to do with the satisfaction score. So we should go ahead and see, okay, what is the relationship between age and other categories, and what is the relationship between satisfaction score and other variables. This might be the reason for having a high VIF score. I go down and I would like to see the relationship between age and all my columns. You see, this is the relationship between age and all my columns, and you can see age almost has nothing to do with any columns as a multicollinearity. So it means age doesn't have any issue, and we can go ahead and see about the satisfaction score, also satisfaction score. So why the VIF is so high? It's because of the noise that we have in our data, because the data set that we have, it's not 100% real data, definitely, because of the data privacy. It is pretty close to mere data. It means I had to modify some information in our data, and that modifications led to have some multicollinearity. But just because during the project I'm going to use some tree-based models or ensemble models, we don't need to worry about the multicollinearity. Multicollinearity is only important when we want to use linear model. And we are not going to use any linear model, so we don't need to worry about the multicollinearity. So this is the exploratory data analysis, and we can go ahead for the next step, which is preprocessing. The next file is preprocessing. Again, the process is the same. The first step, we are just gonna import the libraries that we are gonna work. We are gonna work again with SIS, the pandas, pathlib, just working with different libraries and packages and paths and folders that we have in our project. And here, I'm going to import something from Utils file. The first one is feature, and the second one is two things from the Utils file. Let's talk about the features. If you remember in feature file that we created, saved in Utils, if I go here, in Utils file, we have one file as a feature, and now this is the time that I'm going to use those features. Also from Utils file, I'm going to import two functions. One class for preprocessing and three functions for load the data, for split the data as a strategy function. Two functions and one class. And for feature, you remember the Python file. We have numerical list, we have categorical list, we have target column, we have a remove column list. I have to import all those functions and lists for preprocessing notebook because I'm gonna use them now. So the next step, I'm going to use the load function and just load my raw data again in raw CSV file. And again, you can see the file that we have. This is what was, but this time we are going to do some pre-processing of data. The first step, I'm going to drop some columns because I don't need some columns. And what I'm going to drop, I'm going to drop remove columns. And if you remember, if I just open the pre-process file, you see in feature, we are just gonna remove customer ID. So now here, we say is in this section, I just put file here, just side by side. Here, close it. We say we are gonna remove the customer ID in feature file. About the split, now if I just open the split, let me just bring everything here to have everything next to each other. Okay. The next step, I'm going to split data, but I need something. First of all, I need to say what is my target column. My target column is here. From the feature file, the target column is will repurchase, and I put it as a target column here. And I need to just mention what is my features, what is my target. My target is target column, my feature is everything except the target column. Also, I removed the customer ID. And now this time, I'm going to split just the train and test data. I'm going to use this function. Let me just close the functions, everything to see all the functions. I'm going to use this function here, split the function, and now this time I'm going to use that function. And after splitting the data, now I have 4 different files. I have xtrain, I have xtest, I have ytrain, and now I have ytest. That we can do whatever we want. The next step, which is very important, this is pre-process step. In this step, first I need to say what is my numerical list and what is my categorical. My numerical is coming from feature. My categorical is also coming from feature. And I mentioned this is my numerical, this is my category. Hey, pre-process. If you want to pre-process my data, make sure for numerical column, you are reading only this column. For categorical, you are only reading this column. And now that we mentioned what is my numerical and what is my categorical, I go for do pre-processing. And this time, I use this class, Preprocess Manager. For Preprocess Manager, based on what we set in the utils, for train, just because we are going to the train, we do both fit and transform. We put both of them. And we use 2 things. We use categorical and we use numerical. And this is just the X train, because this is just a train data as a whole. Then we split it to numerical and categorical, and then we apply pre-processing for all of that. And this pre-process only go with the train section. Only apply these sections. You see, here we are only using this function, fit, transform, train, only this one. But if I want to go with the test, now this time I'm going to use this function because this is for test. So what is the difference between 2? I explained in utils. Again, I say for the first function, we use both fit and transform, but in test, we only transform. If we fit, we go and have the data leakage, which is very harmful for the project. Then we have everything. We have a pre-process. Let me just close everything. We have everything. We have a pre-process. We have for the train and test and target. We saved all this file here in pre-process section. We push all the data inside this folder. Previously we had raw, now we have process data. This is just the second step for the notebook, and now this time we have 4 different files as a pre-processed data. If you want to see how the data looks like, now this is, you see, we have the scaled numerical, and we have also hot encoded or labeled file for train, and this is for test. In terms of the number of the columns, they are totally the same, but this is the raw data, and we converted after all this process to this kind of data. And this is the magic of data pre-processing section. All right, now we can go with the next notebook, which is balancing. Again, in balancing, we need to work with the features. I just put it there, and utils also. Okay, let's go step by step to see what we have. First of all, again, we are just gonna import some kind of libraries. After that, from the utils file, we need to import something. I import the load data for loading the data. I also need to import one more library, which is one more function, which is called, let me just close it, balance. But what balance does? It starts doing some steps to make sure the data is balanced or not. It just shows the number of the person for every single label, number of the records that they have. I imported those functions, and now this time I'm going to import the data. Again, the data. I import that data, and now we just make sure how many number of the labels do we have. For example, here you can see 62% are label 1 and 73 are label 0. We have some kind of imbalance data, but again, just because we are going to use a tree-based model, all the tree-based model and ensemble models can handle the imbalance problem in a data. So we don't need to worry. I just run this notebook to know what is the distribution for the imbalance data. If this imbalance was so terrible, we could some kind of handle, but this percentage is handleable by tree-based models. Okay, this is just the last notebook for our project. Now we can go for the next step, and we are done with the notebook section. All right, now it's time to see what we can do for machine learning. Now we are familiar with the data we pre-processed, and the data is ready to build the model. But building the model, it's not just as simple as working a different notebook, run different models to see which one is good. We should track the experiment. Every single model might have 100 runs based on different parameters. We cannot write down on a paper and compare them manually because these are super complex. For my project, I'm going to use 4 different models, and each of them has a few runs. But in a real scenario, you might have run 50 different algorithms, and each of them have 100, 200 runs. So it is very difficult to track them manually. So that's why I'm gonna use MLflow for this section to track all the experiments. Okay, let's start to see what we can do for this section. For experiment, you can see I have one folder as MLrun, and it stores everything that I run for experiments. I'm not gonna open this folder because you can't see anything. For example, if I open it, you see some, very weird number. They are just the experiment ID and run ID. It's not useful for reading like this way. Instead of that, I'm going to go to MLflow UI and see how I track the experiment there instead of opening this folder. But I also have two folders. One file is base model and one file is tuning. First, I'm gonna start with base model. In base model, we just run different algorithms to find the best one after tracking an MLflow. After that, we are satisfied with one of them. We pick that one and go with tuning py in Python script to try to make it better, to do some hyperparameter tuning with Optuna library. Okay, let's start with the base model. First of all, I'm just import all the libraries and the packages that I need. You're familiar with most of them. I just say I'm going to use LightGBoost, XGBoost, logistic regression, and random forest to pick which one is working as the best model for my project. I also import some libraries and functions from scikit-learn to just track some of my metrics, for example, accuracy, precision, recall, F1 score, and so on and so forth. And for my project, just because we are working on imbalanced data, recall is the most important one. Recall 1, because we have two labels, 0 and 1. 1 is important because they are predicted as they're going to repurchase, and this is very important for marketing. So let's go for the next step. In the next step, I'm going to set my direction. By this code, it doesn't matter where this file is stored. After running this, I jump to the project folder, and it means this is the base direction. Now, whenever I need it, I can just add like this way, which folder, which subfolder I'm going to go into details. This is very useful, and I use the pathly for my projects. In the next step, I say, what is my tracking path? My tracking path is here and this folder. And this is ML runs. I said, okay, MLflow, store all the tracking, all the metric that you want inside this folder. However, I know you are storing on your UI, but store is here just as a log. And then the next thing, MLflow should set tracking ID. If I install MLflow on a cloud like Azure or Amazon, I should go with create some virtual machine or these kinds of things. But for the sake of this project, I just installed it locally. Otherwise, if I, for example, install MLflow on Amazon, instead of this tracking ID, I should use the URL that Amazon Web Service gives me. But for my project, my URL is the local, is these sections, because I didn't want to use the cloud for this project. The next step is that I'm going to say, okay, this is the script for running the model, but every single model needs data. Where is the data? And as you know, data is here. It's in the pre-process sections. In a notebook, we stored all of them in the pre-process. So all this data, all of them are coming from these sections. And this is super crystal clear that we are going to use these data for training and testing or evaluating the model. In the next step, I'm going to say, okay, I'm going to have the experiment in MLflow, but what I can call it? I'm going to call it as a baseline models. Why? Because in this experiment, I'm going to find which model works better. So I call it baseline model. And after that, again, my model should know what is numerical column, what is categorical column. For target column, we don't need to import Y because we have a feature as a target. But for pre-process, we should know which of them is numerical, which of them is categorical. However, the data is pre-processed also, but a model should know which of them is numerical, which of them is categorical. Okay, here we have, if I just collapse them, we have 4 different models: LightGBoost, XGBoost, logistic regression, random forest. The structure for all of them is the same. I just explained one, and then we can go to the UI for tracking to see how I tracked them. For example, for this one, I start with this section. First of all, we need to make sure the path of the file is there. After making sure we have training and we have testing data, we go and create some variables and read those CSV files. In this section, we just create the path. We didn't read the data. But now here, we just read the data with pandas library. Then we try to train model, and I call that run as a LightGBoost. It means inside the experiment, which is called baseline model, now we have one run, which is called LightGBM. For the other model, we have XGBoost. The other model, we have decision tree. Finally, inside that experiment, we will have 4 different runs. Again, what we are going to do here, we have here the model, the default LightGBoost. For default, I just put the random state. We have an estimator, we have learning rate. It is B for hyperparameter tuning. I just put it as a default. For every single model, I put the default. And then after that, we just go and train the model. In this section, we train the model. And then after training the model, I test model. Again, here, just because we pre-process data in the notebook, we didn't need to pre-process data here because this is after notebook. But in the next step, which is later on for the project, when we go with the pipeline, in that case, this is a different story. We should pre-process data during the modeling because it's going to be the real scenario for the real prediction. And after that, everything is ready. We train the data, we test the data, we log whatever we needed. First, I log the parameters, which kind of parameter I used for my model. And then I log the metric that I need. My data is imbalanced, so precision and recall are super important for me. So I only store those. This is for one model. The other model is exactly the same, everything. The only difference is here. The model for XGBoost, the parameters are different, and also the run name. The rest, everything is the same. Also, for example, for logistic regression, again, everything is the same except 2 things. Logistic regression model definitely is different, and the run name. And also the last one is for random forest. For random forest, here this is the model estimator, and this is the model. Now let's see what I captured after running all these run. As you can see, we have some experiments here, but we don't need them because they are for later. I just cross them to don't get confused. This is the default. Okay. This is the things that we just created. Baseline model. This is the experiment that we created. Now we can go inside that experiment. You know that we ran 4 different models: random forest, logistic regression, XGBoost, and LightGBoost. But inside each of them, as you saw in the sections that I explained the metrics or everything, they store several metrics inside itself. For example, LightGBoost, we have all these kind of metric from LightGBoost. Also, you can see the run ID. This run ID, if you remember the folder that I showed you, there are folders and subfolders with so weird naming. All of them are the run ID. That's why I didn't want to explain there. But here it's so more sensible. Also here, for example, you can see we have some kind of parameters that we built and trained model based on these parameters. But this is only one of them. What about the other one? For XGBoost, we have its own metrics, its own run ID, and its own parameter. About random forest, the same. You can see random forest works very well on training, but for test, no. So definitely random forest is overfitting. And about the logistic regression. But how we can know which of them is good? It's easy. Just select it and go for compare all together. So I go and compare all together. Here, we can say, okay, based on what? I'm going to, for example, based on test recall. And as you can see, the test recall for the highest one is coming from, let me just bring the model. Only the model is good for me. The best one in terms of the recall is random forest. But if I go with the other parameters, we will have so many other things. For example, based on precision for 0, or based on a test recall for 0 or 1, we have different metrics. But I don't like this chart, to be honest, because this is super confusing. This is the best section that I can work on it. This is name of all models that we have it here. Random forest, logistic regression, XGBoost, and LightGBoost. And based on the context of the project, we know that for this imbalanced data, having the highest recall for label 1 is very important. So based on that concept, we can see here for random forest, for recall, if I go just a bit down to see recall, okay. Random forest for recall has 1, that's amazing, but for test, it has 87 or 83, sorry. It is totally overfit the model. What about the logistic regression? For logistic regression, train recall is 83, and for test recall, we have 82. They are super close to each other, so we can so far consider logistic regression as the best model. But let's see the XGBoost. XGBoost almost has 1 again and 87. Again, XGBoost has overfitting. But what about the LightGBoost? LightGBoost has 93 and 80. It means based on this factor, we can see logistic regression or LightGBoost. Now let's see for the recall for label 0. You see logistic regression has 62 for label 0 as a train and 62 for test. But LightGBoost has 81 and 61. So it means for overall sections, we can say LightGBM or LightGBoost is our base model. So we can say, okay, this is our model that I would like to select. So LightGBoost is selected as my base model. So in this step, in this experiment, we are super familiar with which kind of models that we are gonna select and go ahead and tune it for the next step. So it means after running different experiments here and analyzing and tracking all those metrics, we made a decision that LightGBoost is our model as a base model. Now we know what is our base model, let's tune it. So I go and open the tune file. In this file, again, we just set the preliminary steps as we did for base model. All the steps are the same, but this time the only difference is that the experiment name is different. I put model tuning as the experiment name. This is the only difference, but everything, the rest is the same. And this time the objective is just I make sure the data is there, I read the data, and I set some suggested experimentation. These are all the parameters that I would like to try for my models. For example, I say for estimator, I would like Optuna just try once for 50, the other one for 30, the 300, and all these kind of parameters just to find the best one. After that, I tried different trials for my LightGBM. And then I just try to train the model, and after that apply and predict and test. And finally, I just capture all the metrics and I log all of them in MLflow. And then when all these steps are done, this is the time for saying, okay, we have 5 or 6 different parameters, and each of them has 3 or 4, the values. This is the time that Optuna as a library should come to play and just try to give us the best number based on a maximize. Why? Because in classification, we are going to work on different objectives, and all those objectives are trying to maximize. And for example, if we were working on a regression model, the goal is minimized because the basic metric is error, and lower error, better model. But for classification, that we are just gonna working on recall and precision, having highest recall and precision is very important for us. So yeah, this is just a tuning. Again, after running this model, it means after running this script, this time we are going to have 50 different runs based on this number, 50 different runs. It means now if I open the MLflow, just one of them, I think this is, you see we have 50 different runs. All of them are coming from this script. But again, I don't want to open this folder, and instead I prefer to go to MLflow. And now here in MLflow, we are going to work on this experiment, model tuning. I go and open model tuning, and as you can see here, we have many different runs, and each of them has its own metric. For example, this is run 38, we have this kind of metrics. If I come back, for example, run 13, we have this kind of metrics. This is the parameter for trial number 13, based on those parameters and hyperparameters that we put based on the combination that they have. For example, for number 3, we have these kind of parameters, and this is the result. But how I can know which one is the best? MLflow can help us, and we don't need to do anything manually. Based on that maximize that Optuna said, MLflow just selects the best run as the best params. This is the thing that we only need to open it, and this is the final result. For the best one, we say F1 score, this is our objective, and we want to maximize it. And out of all those 50, MLflow guarantees that this F1 score is the highest one. So based on which parameters, based on which combination. Again, MLflow can help us. MLflow say, okay, if you put all these parameters for your model, for your LightGBoost model, you can reach to the highest F1 score for your model. Now we know which model, LightGBoost, which parameters that we just got it here. Everything is ready. We do all the steps for experimentation and exploratory data analysis and pre-processing. Everything is okay. Now this time is stop all these kind of manual process, different notebooks, different runs. Now this time I'm going to do all the process from the scratch to building and evaluating the model and finding the final score based on the best model, based on the best parameters, just as a pipeline, just one touch, different components, just one touch. And this is called training pipeline. And we are gonna do it in the next step. All right, this time we should go to the training pipeline. As you can see, we have different folders here. We have components, we have data, metrics, model, and pipeline. We can go one by one to understand what's going on here. First, I'm gonna start with the components. In components, we have three different components. First, we ingest the data. After that, we pre-process the data, and then we train and evaluate the model. Let's start with data ingestion. Data ingestion, we need two things. We need to first grab the raw data that we have in the raw data. This is the file that we are just selecting, and after that, we just input it, and then we store that file inside this folder. When we grab the data from the raw data, we store it inside the pipeline. We just grab the data and push it there. This is just data ingestion. And then after doing that, we need to make sure the data doesn't have any duplication or anything. When it's done, the data ingestion is finished. After running this specific component, we will have raw data CSV. This is just this file with a different naming. This is just the raw data. So from now on, we don't need to work with this folder anymore. Again, as I said, in training pipeline, we are doing all the steps from the beginning of the project till now from the scratch as a pipeline. We don't need to go or open the notebook, do this different experiment or do these things. We know everything now. Now we are gonna just put the steps as a chain next to each other. After having the data ingestion, it's time to go with data pre-processing. The data pre-processing, the first step is that I'm going to say, where is the file my raw data is stored? My file is here. It's just a training pipeline. I just put it there as a raw data. And as you can see, the naming is just data CSV. We just save it. The next step is that, okay, now you know the data, but where you're going to save it after all these pre-processed sections. I say, okay, after running everything, go for the data processed folder, which is this folder, and push everything inside it. Now we know the input, we know the output folders. But we also need one more thing in a data pre-processing. If you remember, in Utils folder here, we have very beautiful processor file, which is processor pickle, which comes after running that class that has training processor and testing processor. And after that, we just saved and dumped this processor pickle. And I told you during the project later we need it, and this is the place that we need it. Because previously during the experimentation, with different functions, different things, we were satisfied that this processor is the best and it works on all the models. We were satisfied all the metrics and say, okay, this is a processor that I like it because it can handle the numerical and categorical. So I save it somewhere, and whenever I need it, I just call it. And this is the time that I'm calling that processor. Now we have everything. We have the input, we have the output. But we also need functions for running this pickle file and even some kind of split the data. Now this time, we are going from Utils, we are going to bring processor class, because those class for working pickle file needs the function to be there. So I just import the processor. I also need to bring another function for splitting. As I said again, we are doing all those steps that we did in Notebook as a script. to make them modular, to make it reproducible. I also need to mention which kind of features that we need. So I got it from the feature Python file that we previously created. And in that file, we mentioned 4 different lists: remove list, target list, numerical, and category. Now everything is there, we can go ahead. This is the main function for data processing as a next step of the pipeline, which is the second component. First, we just make sure about the direction, about everything. If it's not there, the script creates. Then we go for the next step, and this is the time. First of all, we should drop the target from the X to declare which is the X column, which is the Y column, what is the feature, what is the target variable. And one step before doing that, if you remember, during the data pre-processing, we remove some columns. So in this step, we remove those columns. Then everything is fine. We remove that column. We say, okay, what is my target? What is my feature? This time, I just split data. And again, I use that function that I previously used. Why I prefer to have a utils? Because in this case, I have consistency for working my features, working my function. It means the function that I'm using right now, the columns that I'm using right now, all the settings that I'm using right now for the class, function, everything, they are exactly as same as what I did for notebook, what I did for the previous sections. And in that case, I have consistency. So we can go ahead. Now we have splitted the data. This is the time that we are just gonna pre-process data. Again, for train, I use fit and transform function from preprocess manager class. But for test, I use another function which is called transform test. It means 2 different functions in 2 different sections for 2 different data. The first one is for training. The second one is for test. Now, this is the time we saved all this file. After running all the above steps, these files are just gonna store here. All of them are there. If you remember, the process so far is the same as the one that we did before, but that time we go with different notebooks or different things. But here we just have one script. And even it might be even better when we create pipeline, because there are 3 different components. Here we have component 1, component 2, component 3. After that, we create one pipeline, and just with one touch, we have everything. Okay, now we talked about data pre-processing. So far we saw 2 components: data ingestion, data pre-processing. The next component is model building. Okay, now this time we are gonna work on model training. During the experimentation, we were familiar that, based on MLflow tracking, we know that LightGBM is the best model. And we were so familiar that which kind of metrics that we are going to use after hyperparameter tuning with Optuna. But this time, we are going to just again build the model, exactly that parameters, that hyperparameters, everything is the same, but as a script and component. Again, here, I just initially read the data from the data here, one for test, and this is for train and test. Now running everything about the data. This is the experiment name that I'm gonna say. This experimentation is called training script, because this is training, same as the previous sections that we did with notebooks. First in notebooks we found baseline, and after that tune. But here we don't need to tune because we know which parameter is useful. We only call it training script or training pipeline or whatever you want to call it. Again, we need the numerical column and categorical column, as same as the previous one. Here, this is the place that we mention which kind of parameter that we want to have, and this is exactly coming from MLflow. Where it's coming from, if I come back to here we have model tuning, and inside the model tuning we have something best params, and here all those parameters that we see here. And I use these parameters inside the script because I'm going to declare these parameters for my model. I just say, okay, these are my parameters for building the model, and I declare them. So later, this time, I'm going to first make sure about the data folder is there or not. This is exactly what we did during the experiment for base model. First, we should find and make sure the folder is there or not. After that, we read the data. And now here, I'm going to build my LightGBoost based on which parameter? Based on those parameters that we just declared above. All these parameters, all of them are coming from these sections. All of them are coming from these sections. These sections, all of them come and fill the LightGBoost parameters because they are the best. After that, we need to just store two things because it's the last step of the pipeline. And after that, we need two things. We need one, the metric, the other one, the model. Metric is going to go to this folder, and model is going to save here. Also, both of them are achievable in MLflow UI, but I would like to have it here just as a reference. And model is gonna have as the pickle file, and the metric is gonna be a JSON file. Before opening these two folders, I prefer to explain the rest. After pushing everything, I just ran the MLflow and I just say these are the metric, all the calculations, and log all the metrics. And then I store everything I needed in that JSON file and save the file. Okay, these are the last components. I'm not going to show you the metric and models at this moment because we shouldn't run components separately. I mean, we created data ingestion, we created pre-processing, we created model training. We shouldn't run manually. So far, I just explained, okay, after data ingestion, you should have the data inside the row. After the pre-processing, you should have data inside the pre-process folder. After model training, you should have two things, one for metric, one for model. But we should do all together. I mean, with one touch, everything should be done. With one touch, the raw data is there. After that, pre-process is there. Then model trained and metrics and models should be stored there. But how we can do that? We should have a DVC file. This is DVC YAML file, and this is just a map. This is just a guideline for all the components. We say, what is the stages? We have 3 stages. Stage number 1 is data ingestion. Stage number 2 is data pre-processing. Stage number 3 is data modeling. Exactly the same as in a component. And for each of them, it said, what is the input? What is the output? For example, the input for data ingestion is that data, raw data. And the output is go to the data raw data. For this one, what is the input? The input is there. And what is the output? The output, if I go there, the output for all these 4 go to process data. And what is for model training? What is the input? All of them are pre-processed. And what is the output? The model should go to the model and to JSON. One for training, the other one for testing. These are all the steps as a chain, one after each other. So based on this DVC, we should create another file is here as a pipeline file. And this pipeline file is gonna do all the steps. First, it's gonna read the data, and it's gonna end with all the steps as stages here that we just explained in the YAML file. After running this pipeline code, only we need to run this pipeline. I mean, inside the training pipeline, we only need to run one file, which is pipeline.py. After running it, everything is there. We will have model, we will have pre-processed data, we will have raw data, we will have metric, everything. But again, I don't want to see the metrics or the file here. Let me just open. For example, for model, we have the pickle file. For metric, we have this JSON file. These are the parameters, these are the run ID, experiment ID, and all those metrics. Also, if we go to the MLflow, we can see all these things there. For example, in MLflow, if I go here, you see we have one file which is called training script. It's here after running that pipeline. When we run that pipeline, we have one experiment here. And this experiment is coming from the last component, model building. If you remember, one function in that component in model building was training script as the experiment name. If I go inside the training script, we have one model, one run. This is the LightGBM. This is the LightGBM, and this is the all metrics. And even the model is registered here because we logged the model also. If I go to the models, this is the model that is registered after running the pipeline. I go to the model and go to the artifact. You see all the information about the model. When we want to deploy the model, we have the requirements, we have the model metadata as a signature, we have the Python environment, we have model itself, we have conda YAML, and we have ML model. This is very useful for ML engineer when we want to deploy the model. So even if we go to the register, we can see we have LightGBM as the model. All right, now we were familiar with all the steps with training pipeline. If I want to recap so far, the training pipeline, this step, is just encapsulate all the steps for these sections. The notebook, the experiment, the data, and the utils. All of them encapsulate in 3 components and then one pipeline as a training pipeline. Now it's time to deploy the model, am I right? Yes, but before deploying the model, we should do some inferencing as a test to see model is working or not in isolated sections. So I create one stage as an inference to make sure my model is working correctly or not as unseen data. Because so far we built the model, test it, train it, and the data, splitting data, everything. But I need to do this step from the scratch as a test. I put unseen raw data, totally raw data. It's not pre-processed, not anything. And after that, I would like to apply the model and the pre-process and all the steps and get the result to see whether the model works or not. So we have inference. I created the inference. I put something here and I would like to explain to you. First of all, I import the experiment ID and run ID to bring the registered model. If you remember, we registered the model in MLflow. So I just bring that model. I also bring the preprocessor from the utils file to preprocess my raw data. Then I have some functions. First of all, I'm going to set the URL based on a tracking URL for MLflow, definitely. I load the data, just the raw data that we have. This is just the raw data I just created. This is the sample new data. I just load the data. Then I'm going to do all the steps for pre-processing. I removed that column. We don't need it. Do you remember we removed one column as the removed column? We remove that column. Here we just make sure, do we have any missing column or not? But how we know? based on the feature file that we have in Utils, we should have 16 numerical and 11 the categorical to make sure that raw data is coming as a new data. Does it have all the columns that we have? Later, we need to pre-process data, and this time again I use the pre-process data, but this time I'm going to use only one function, transform, not fit and train, because this is only for training. This is for test, and the new data is the same as the test data. So I just only use that function of the class. The class is this class, but I only need this function, transform data. And then when everything is done, I just push the data as my final result. I also saved as an MLflow search. However, I didn't use that one because this is just for inference testing. If I want to show you the data, it was the raw unseen data. I just put very random data, and as you can see, it doesn't have any column as the purchase because it is the column that we are going to predict by model. But all the necessary columns has, even it has the customer ID because preprocessor is going to drop this column, not manually. And this is the data. But after applying the model, this is the final result. Now we have these columns, the new columns. We have prediction 0, 1. It means for this case, it's not going to repurchase from us, but this case, it's going to repurchase. Why? Because the probability of 1 here is higher than 0, that's why it's 1. And here, the probability of 0 is higher than 1, that's why we have 0. This is just a sample. Now we are super confident that the model is working, all the pre-process step is working. Now we can deliver this package to ML engineer team, or we can just try to see can be deployed or not. Now for this time, I'm going to go with deploy the model. First of all, I'm going to go for the script, and this is my script file. And here I only need to PyFunction. To be honest, for this one, I used AI coding assistance to know what's going on, because deployment for me, it's not my the main skills. I'm familiar with the concept, but for coding, definitely for deployment section, I use AI code assistance. So first of all, we created the PyFunc model, and this helps us to encapsulate all the process, all the steps that we did from the project. For example, we need to make sure which kind of columns do we have, which kind of numerical, which kind of categorical. After that, which kind of columns we do want to remove them. Then we do all the steps for pre-processing. We drop the columns that we don't need it. We scale the numerical column. We encode the categorical, binary or one-hot encoding or label encoding. After that, we apply the prediction on a new data. This is just PyFunc model. And then when creating the PyFunc model, we go and create one whole script. This script is working the same as PyFunction, but here we explicitly say, okay, if you want to do the pre-processing, where is the file? For example, for pre-processing is here, process pickle. If you want to use the feature, where is the file? It is in the Utils. If you want to use just the data as a sample, which data you can use? Or where is the model stored? All these sections. Again, the process is the same as PyFunc, and after that everything is done, we just track the model as the final result for the deployment. However, deployment doesn't need MLflow tracking. I just logged it here, and the inference is very important for deployment. We need to have the input example, and we need to have output example. Input example should come from the feature spec, and feature spec is those kind of feature file that we just defined, and the output example is just based on an output that we just give one example. And later we should say which kind of dependencies and requirement we need. And finally, we need to store three things: the model, processor, and feature spec. When everything is done with the register the model, then we can create the application. This application is just the interface for the users to deal with all these kind of steps. Again, all this process is beyond the data scientist skills, but if you know, this is the bonus. Okay, after running that one, we have leading scoring service. This is just the name of the project. We go there, I just run it twice, one version and version 2. This is the one version we just created. You see, we have some kind of signature. We have inputs that we said we need the customer ID, we need the age, we need the annual salary. All these features coming from that feature spec that we created, and all of things. And we need one output just as a prediction. It is long. It means it's the number, integer number, float number. This is the model, registered model that we just created here. And whenever we need it, we can just call it with the API. And just because I didn't deploy this model in cloud, I had to create the frontend for myself to mimic the internet. And I'm using the FastAPI API to create the API between that frontend and this model. Let me show you. Okay, here, this is, I just explained, this is what I saw in the MLflow. We have signature, we have all the models and all the features. This is the API. And this API is responsible to call the model. But we need some kind of interface to talk with this API. So I created the front end, and this is the index. This is just a simple HTML file based on my taste. It has some kind of HTML code and CSS code to create that interface. Now this is the interface. This is the model. How we can connect this to each other with API. Okay, now I'm going to show the final application after coming all this journey, but we cannot run it HTML file like Python file as a terminal. So I created as a front end. I go inside my folder and just open the index.html. And this is the final application that we created after all those journey. We have the customer ID, we have age, that this is just not number, we have gender. The options are exactly the same as the raw data because the model trained based on this kind of model. We have countries, we have, for example, company size, we have industry, we have job title. I just categorize each of them. For example, this is the company info, or this is the purchase behavior. How many number of the months they are the customers, or have they churned before or not? Have they ever used the discount, number of the purchase? Even one section is for product usage. Based on a month, how many days they have been using the system, what is the average session duration, features they are using in our applications. Also, how many APIs they call. This is just a product. This API has nothing to do with that API. This is just one feature. And this is just the supporting and ticket, number of the ticket, average ticket resolution, how many of them are solved, satisfaction score, and so on and so forth. For example, I want to say I have a customer from Canada, 36 years old, for example. I'm a male. The company size that I'm working, and this size for the tech, just as a developer, whatever. I just put it 2 million. My company is using as a starter. I have been using the system for 20. Total spend, I spent 4,000. I just number of the purchase that they have 3 times. This is the fine. I've never changed. I've never used also any discount. For months, I'm using 15 months. The average of the system is, for example, 10.05. Number of the features, we just only use 4 features, and we only use 1K product tour. Onboarding completes, I can say no. Supporting ticket, we have 3. Average ticket, we have 5. Satisfaction, we can say 3. Campaign, 2. Marketing touch, 15. Attended webinar, no. Social media, yes. Now we can predict based on these data, will I repurchase this product or not? If I click on the predict, you can see no, definitely based on this data, I'm not gonna repurchase these things because 72% is just not repurchase, only 28% is for repurchase. But if we go with the different data, yes, for example, for different data, we will have different percentage. These are just end-to-end machine learning project. As a data scientist, I know there are so many different steps. After this step, for example, we can deploy it as a real application in some kind of host, for example, cloud or any host server. We can do some CI/CD pipeline, but those things, I guess they are beyond the data scientist, but I don't want to go for that because the complexity is too high for making as the project tutorial video. I hope you enjoyed this video and thanks for watching.